Hello everyone, my name is Abhishek and welcome back to my channel. So imagine you got an opportunity to work with MNC as a DevOps engineer. And at this point of time, the developers of the MNC, they are using microservices architecture and the services are already containerized. Through Docker Compose, they are deploying these microservices onto the virtual machines. Customers access these microservices through a load balancer. Imagine this is the setup that they have. And once you join them as a DevOps engineer, you are asked to onboard this entire thing to Kubernetes. They have absolutely no idea about Kubernetes. So you have to set up things right from zero. Before that, you need to design the solution. For example, understanding the requirements, understanding resources that are required for scaling the Kubernetes or defining the size of the Kubernetes, number of nodes, number of namespaces, CPU that is required, memory that is required. Along with that, you should also design their lower environment, staging environment, production environment with all the best practices. How would you do that? This is exactly what you're going to learn in today's video. And the best part of the video, I'll not directly jump onto the production environment, but I'll explain you multiple levels that are involved in achieving this particular task. Designing Kubernetes is not a single day activity. So this takes through multiple days, even months at time. So that's why DevOps engineers usually do this in multiple levels or multiple phases. I'll tell you what are the 6 different levels that are involved and what exactly takes place at each level. This video is going to be quite interesting. Just make sure you watch it till the end. As I told you, designing Kubernetes is not a single day thing. So everyone should start from level 0. What some DevOps engineers do is they directly create a Kubernetes cluster, randomly pick up one of the microservices, and deploy that onto the Kubernetes cluster. That is a complete wrong approach. What you should do is first, you need to focus on requirement gathering. To understand requirement gathering better, let's take example of MNC. Let's say you got opportunity to work with Amazon and you'll be working with Amazon e-commerce. So what exactly you would do as part of the requirement gathering? Although Amazon e-commerce is a one single application that you see, either on your mobile, you just install one application, or through the browser, you just access one application, but they are made of multiple microservices, right? It looks to you like a single application, but it is made of multiple microservices. For example, UI can be a microservice, or UI can be made of bunch of microservices, and payments can be a single microservice or group of microservices. Payments microservice, DB related to payments, supporting applications for the payments microservice, maybe one service that is providing required configuration for payments. Similarly, transactions, some shipment, right? Delivery related ones. There can be multiple microservices. So at the first step, you will first understand what are list of microservices. So once you gather this information, then you will understand what are the teams that are working on these microservices. It's not possible that there is only one team that is working on all of these microservices. Instead, there will be bunch of teams. And how this isolation is done, what majority of the companies do, if there are 3 services related to payments, for example, the payments main service, database of payments, configuration, supporting services of payment, they bunch them or they group them and they dedicate these microservices to a team. Maybe they call it as a payments team. Similarly, then can be transactions team. There can be shipment team. or there can be a UI team. So you need to understand what are the teams that are involved in building this application. Going ahead, this will greatly help you in defining the namespaces of your Kubernetes cluster. After that, once you identify the microservices and you identify the teams that are working on these microservices, you should identify the less critical microservices. That is, imagine there are 300 microservices. Out of these 300 microservices, you should segregate them into less business critical, medium business critical, important, and critical microservices. Why is this required? Because you will not onboard all of the microservices at once. You need a plan. So can you migrate all the microservices from virtual machines to Kubernetes at once? You cannot do it. So what you need to do, instead break this into less critical, medium, important, and critical microservices and start working firstly on the less critical ones, then on the medium ones, then on the important, and finally the critical ones. Of course, you will not work during the requirement gathering, but at the requirement gathering phase, you will prepare a sheet with these details. I'll also show you the sheet in a while. Now comes the most important thing. And and if you ask me personally, this is the most important thing of the entire Kubernetes design, identifying the resources. What does that mean? Because your microservices are already with the virtual machines, right? You must have observability setup. For example, this information might be in Prometheus, right? What information? The CPU utilization, memory utilization, disk utilization. You should get this information from your Prometheus stack, that is Prometheus or Grafana or other sources, right? Let's say you have not set this up. These microservices must be deployed on EC2 instances, at least, right? Or Azure virtual machines, even through the AWS billing console, or maybe through AWS CloudWatch. From any sources, monitoring dashboards, you can actually get the information of CPU utilization, memory utilization, and disk utilization. This is the most important thing because using this, you can compute or you can calculate the exact resources that are required, at least at your lower environment. Okay, you might not use the same resources for your production environment because you might set up high availability, you might set up multi-region, but at least for your lower environment, this calculation is super important. Otherwise, how would you define the size of your Kubernetes cluster? Like, would you create a 50 CPU, 50 GB RAM Kubernetes cluster, even though you don't need it? No. So you will first identify the resources using Prometheus Grafana or at least through the AWS billing dashboard or Azure dashboard. And according to these resources, you will start building your Kubernetes cluster at later levels, not in level 0, right? But you will put this information in a sheet. Fifth one is cost. For your management, end of the day, cost is the most important thing. If you tell the management that, okay, we will onboard Kubernetes, but it is going to charge 10 times more of what it is costing to us currently, but the performance will be good, probably your management might not agree to it. It should be always a balance between cost as well as performance. So you should calculate the cost. How would you calculate the cost? You might ask me this question. If you have this particular thing, it's not that difficult to calculate the cost because just go to your billing dashboard, see how much AWS is going to cost for the CPU that is utilized, how much AWS is going to cost for the memory that is utilized, and compare that. So you can get the current costing from the AWS billing dashboard and compare that with EKS or maybe AKS or maybe GKE wherever you are trying to onboard the Kubernetes cluster, provide this information to them, the cache calculator, and it is going to tell you approximately what it is going to cost for your organization, right? So in the requirement gathering phase, one, you will first list the microservices. Second, you will list the teams that are working on these microservices. By going ahead, it will help you for logical isolation within the Kubernetes cluster. I'll talk more about it. Then you will identify less critical, medium, important, and critical microservices so that you can work on this entire migration from VMs to Kubernetes within phases. Then you will work on the existing resource utilization because this will help you define the size of your Kubernetes cluster. It will tell you how many nodes you need to create or how much CPU and memory is required for your Kubernetes cluster. Finally, costing. Now, once you get all this information, try to put that in a sheet. For example, this is the sheet. Now, this is something that I have designed basically for this example. So I've taken 100 microservices. So you can see here, shipping service, payment service, authorization service, tracking service, recommendation service, everything that a e-commerce application has. I'll also put this sheet on the Telegram channel and also a Discord server. Discord server is for members only, but Telegram channel is public. Everyone should be able to access it. Okay, going back. So these are list of services that I have noted, and I have also identified the teams that are working on these services. You can create a simple filter if you know how to use Excel. Just create a simple filter. You can create a filter on platform and you will identify the services that are related to the platform. For example, this is the one, this is another one, right? And then the CPU utilization. I have noted rough values of the CPU utilization, memory utilization, business impact. Again, you can filter it out. This is the critical one, this is the critical one, this is the critical one. And onboarding priority, critical ones are highest priority. Uh, Similarly, important ones are second important priority. Estimated cost, environment readiness, that is as you keep working on these services, not at level 0, but at level 1, level 2, you can update this sheet, something that I've updated. At level 0, everything will be not ready, right? But randomly I've assigned some values as ready, in progress and all. And the migration timeline. So this is the sheet that you prepare and share it with your management, right? Now this concludes your requirement gathering phase. This is a very, very important phase. A lot of people tend to skip this phase. And what a lot of people do is they prepare this document, but they don't discuss this with the development team, management. They just keep it with themselves and they just keep working on it. No. Once you prepare this document, share it with your management, share it with your development teams, discuss the plan, and let them know what we are going to achieve in the next 3 months, in the next 6 months, right? Okay, so this is about requirement gathering. Now, once the requirement gathering is done, because you have these values, do not directly jump onto creating dev Kubernetes cluster, staging Kubernetes cluster, and prod create prod Kubernetes cluster. No, again, you should not be doing it, but start with a proof of concept. How do you know if these microservices would even work on Kubernetes, right? There can be some issues as you move them to Kubernetes. Instead of doing that on a dev environment, instead of doing that on staging or prod environments, first perform proof of concept. How would you perform proof of concept? Abhishek, there are 100 services. Should I perform proof of concept on 100 services? No. That is why we have assigned the services with the business impact. Take 5 services from critical. Take 5 services from medium, less impact, important. So you will Identify some 15 to 20 microservices, perform proof of concept on these 15 to 20 microservices. So at this stage, just create a small Kubernetes cluster. For your proof of concept, it is okay if you create a Kubernetes cluster with maybe three nodes, uh, three data plane nodes, three control plane nodes, and each with maybe 8 CPU and 8 GB RAM. Because you're not testing it with customers, or you're not sending it with the real-time traffic, right? So just create a Kubernetes cluster with maybe three control plane nodes, three master plane nodes, so that your control plane also works in the expected way. Then for these 15 microservices, start creating deployment manifest. And make sure you pick the items in a way. Some of them use deployment, some of them use stateful set. That is, pick a combination of stateful applications and stateless applications. Maybe you can pick up one DB, one application, one caching server, one queuing server in that way. So prepare deployment stateful set or daemon set for these microservices. Prepare Kubernetes service for them. Prepare ingress, right? Pick up ingress controller. Now you might ask, but Abhishek, how do I know which ingress controller should I pick up? The easiest thing that you can do is go with the cloud provider's ingress controller solution that is provided, right? Probably you can start with ALB if you are on AWS. Perfect. Now test the traffic. Once you create these things, test the traffic. If the traffic works well, and just tell your QA team to run some tests. And if they say it is okay, then you are okay to proceed with the next phase. Imagine if one of these microservices is not ready for Kubernetes. Then you will focus on identifying the issue, right? See why the container or why the pod is going to crash loop back off. What can be done? Maybe you should set up liveness probe, readiness probe. So during the proof of concept, you should make sure everything is tested okay. Important part of the proof of concept is pick up services from various categories. Pick some services from business critical impact, pick some from medium important and less important. Now, once your proof of concept is done, this typically might take up to 30 days as well, because it's not as simple as what I've explained here. You need to create these things, right? Deployment service ingress and ingress controller. Some of them might go to crash loop back off. You have to identify how to set up readiness probe for them, how to set up liveness probe for these services, right? So that the liveness probe and readiness probe tells you that these services are good to be used. So by or setting up all of these things takes a lot of time, roughly 1 month as well. But if you're going with a small team, if you're going with, let's say, less number of microservices, you would probably take 2 to 3 weeks as well. Anyways, so that is about level one, that is performing a proof of concept. Now, then you will head to dev Kubernetes cluster. Level two is where you start the actual implementation. So in level two, with the information that you have from level one and level zero, you will start creating the Kubernetes cluster. Remember, this is the dev Kubernetes cluster. That is, this is lower Kubernetes environment. Now, how would you create the Kubernetes cluster? Abhishek, from the sheet, we have the information that, okay, this is the total CPU that is required, and this is total memory that is required. Let's say this comes up to 40 CPU, and let's say this comes up to 60 GB RAM. Now, just for example. So how would I create my Kubernetes cluster? The thumb rule is that your control plane should always have three nodes at least. If you're going with EKS, AKS, GKE, you don't have to take care of control plane because they are already managing your control plane. Now within your data plane, at least create three nodes. So if it comes to 40 CPU, Maybe you can create 3 nodes with 16 CPU each and 24 GB RAM each. So that 14 multiplied by 3 comes to 48 CPU, 24 multiplied by 3 comes to 70 GB RAM. So basically take something that is more than the required CPU as well as the memory. But Abhishek, why did you take 3 nodes? So one thing that you need to understand, a Kubernetes cluster can be scaled up to 5,000 nodes as well. And each node can handle 110 pods. This is the official recommendation. But the important thing to note, if you have more number of nodes, during the upgrades, you will find it difficult, right? You have to upgrade node by node, which you might find difficult. So always try to keep it just as you required. For 16 CPU, sorry, for 40 CPU, do not create 10 nodes. That will only increase your work. So the recommendation is to have 3 control plane, that is mandatory. And when it comes to the data plane, have at least 3, but you can scale up to 5,000 nodes within your Kubernetes cluster as well. Okay, now that you identified the number of nodes, what about namespaces, right? Within a Kubernetes cluster, you can also create namespaces. How would you define the namespaces? As I told you just some time before, the best isolation for the namespaces is according to the teams. In the sheet, you can see that there is payments team, there is platform team, communication team, and each team is dealing with bunch of microservices. So what you can do, create a namespace per team. So payments team will have their namespace, transactions team will have their namespace, and this will help you with respect to RBAC. What does that mean? You create namespace. One of the primary reason is for RBAC, role-based access control. So what this will do, this will help you with defining access of a developer to that particular namespace. If there is a UI developer, now why should that UI developer get access to the payments DB? There is absolutely no reason for it, right? So UI developer definitely does not get access to the payments DB. So what you can do, if you create a namespace for UI and if you create a namespace for payments, so you can restrict access of the UI developer to just this namespace and access of the payments developer to just this namespace. You can achieve this by integrating RBAC with IAM, right? That is using OIDC provider. We learned this in multiple videos in our DevOps projects. But anyways, this is the concept that you need. So namespace is used for logical isolation, and with the namespaces, by segregating the namespaces, you can build your Kubernetes cluster effectively. Okay. Now, Abhishek, what about the false pods? Some of the pods might create issues because of the memory leaks, because of the CPU leaks. How would you handle that? So what you will do at this point of time, that is in level 2, as you define the nodes, as you define the namespaces, you will also define resource quota. If these things goes above your head, if some of these things are not you are used to, so just listen to these topics after watching this video. Try to Google them, or maybe you can check out our videos for understanding these concepts as well. We have a complete Kubernetes playlist. So at this point of time, you will define resource quota as well as limit ranges. So why is this used for? Now, when you divide or when you split your Kubernetes cluster into namespaces, it should not be the case that one of the namespace is utilizing complete 40 CPUs. You have already gathered the data and you should provide namespaces with exact amount of the requirement or little above what they required. If looking at this sheet, you understand that payments team, like there are a bunch of payment services. So if they need 6 CPU, for example, so for the payments namespace, probably you can set up a resource quota with 8 CPU, just above what they require. And if the pods within that namespace try to access more than 8 CPU, the pods will not be able to do it. Typically, the pods will fail or they will run out of resources. So within the Kubernetes cluster, you should set up resource quota and limit ranges for each pod. Basically, again, within each namespace, you have multiple pods. Just to make sure each pod is using right number of resources, you will be assigning them with the CPU limits as well as memory limits. I'll try to simplify this, assuming there are a lot of beginners. So basically, when you create a Kubernetes cluster, imagine this is the cluster. Forget nodes for a while and just say that this Kubernetes cluster has 60 CPUs. And this is split into 10 different namespaces or 5 different namespaces. Now, what you will do as a DevOps engineer, each namespace you will associate with a certain amount of resources. That is done through resource quota. So resource quota is the maximum amount of resources that a namespace can utilize. So for the payments, you can say, okay, maximum is 12 CPU. For transactions, you can say, okay, 12, 12, 12, and 12. Now, this is how you can ensure that each namespace is using right amount of resources. Now, after this, there is a possibility that within the payments, there are 3 services, right? Again, you have to make sure each pod within the namespace is using the resources that it has to use. It should not be the case that one of the pod is using complete 12 CPUs. Again, how would you restrict that? For that, you can set up requests and limits. So requests and limits is used to restrict pods from using the resources, and resource quota is used to restrict namespace from using the resources. So this is what you will do while setting up your dev Kubernetes cluster so that you can ensure all the teams has right resources to use within the cluster. Now, once this is done and your dev Kubernetes cluster is also working fine, so you can probably ask your testing team to run some tests, or maybe you can ask your development teams to log into the cluster, verify everything is working fine. Again, this might take up to 30 days as well. And once everything is fine, you will move towards onboarding the staging environment. Now that you have already set up the dev environment, staging environment should not be that difficult. But one thing to discuss here is that this can be achieved in 2 ways. There are 2 popular ways of how staging environment can be created. What some companies do, they use the same dev cluster. So the dev cluster that was created in level 2, they share the dev cluster with QE cluster as well. Of course, resources will be increased. I'm not saying you will continue to use the dev Kubernetes cluster with 40 CPU and 60 GB RAM. Probably this will be multiplied, number of nodes will be increased, and they share dev and QE clusters. What some companies do, they create a dev Kubernetes cluster and they create staging Kubernetes cluster, which are different. Companies going with this approach, they segregate the dev Kubernetes cluster and QE Kubernetes cluster with namespaces. Very simple. Previously, they had a namespace for payments. Now, with this approach, they will have 2 namespaces, dev hyphen payments, stage hyphen payments, right? So some companies go with this approach. What some companies do is they replicate the dev environment and they create another one for staging environment. But Abhishek, why is this staging environment required? There are 2 reasons for it. Staging environment is required sometimes to test out the production related scenarios. The issue with the dev environment is that developers have access to the dev environment and they try to test out the things. Probably every day they make changes to the application, and this environment is not similar to production. All the feature development that they do, everyday work that they test it on the dev environment. So this environment is mostly unstable, right? And this is also designed for that purpose. Developers should have an environment where they can test their changes. So dev environment is dedicated for that. But if there is issue in production in future, you need an environment which is stable, right? You need an environment that you can rely for testing production issues. That is where you create the staging environment. But Abhishek, will there be dev environment and staging environment only? No. It depends on companies. Some companies create dev environment, QE environment, staging environment, UAT environment, pre-production environment, and production environment. It all depends on the business criticality. Maybe if you're dealing with financial or you are dealing with very, very secure companies, they need more environments. If you're dealing with some product-based companies, you might not need so many environments because you are good to test with one environment. You are good to have a pre-production environment and a production environment. So going back, these are the two ways of implementing the staging environment, or maybe the QA environment as well. Abhishek, which approach is better? Honestly, I would prefer this approach. If your company is okay to spend little more, go with this approach because there is a proper segregation here. With this approach, you have to make sure your RBAC is very, very strict so that people who have access to your dev payments environment, they are deploying new features, they are making constant changes to this namespace. They should not also do it with the staging environment or with the staging namespace. Imagine there are two namespaces for payments. One is the dev, one is the stage. And if developers are messing with both of these environments, tomorrow if there is an issue in production, you don't have a stable environment where you can reproduce the issue. So that's why if you are going with this approach, you have to be very, very careful with the RBAC. Saying that, this environment, this setup is not that bad. Only thing is that IAM, RBAC, and complexity are the issues with this particular approach. With this approach, you have clear isolation, so there is no issue at all. This is my preference. And how would you set up the staging environment? You would follow exact same approach. So you would create resources. You will identify the resources as per identification of resources. You will segregate the namespaces. And if your company is okay, what I would recommend is create the staging environment with more resources. Like instead of 60 CPU, 60 GB RAM in the previous case, probably you can increase the resources so that you can make it more similar to production. Perfect. Yeah, I think this will make you ready with the staging environment as well. Once you have all of these things, you're good to go. Now the next thing is onboarding the production. Because you have already set up dev, you have already set up staging. Setting up production is easy, but within production, you have to take care of two things. One is multi-availability zone, and if required, multi-region setup. Now, these are the things that are different from dev as well as staging environment. If you want, you can also set up your staging environment with these things, but it would only cost a lot for your organization. A lot of companies don't do it. Going back. So what is this multi-AZ and multi-region setup? When we created the dev environment or when we created the staging environment, we did not bother where actually the nodes are set up. So we were just creating the Kubernetes nodes. But when you deal with prod, you have to make sure that your nodes, first I'll talk about multi-AZ. So your nodes, imagine all your customers are in US East one. So all your customers are within the US region itself and US East one only. So you need to make sure that one of your nodes is in US East A1, 1B, 1A, 1B, and 1C. So that even if this node goes down, a, a availability zone end of the day is a data center, right? What is an availability zone? Availability zone is a data center. If this data center goes down, you still have these two data centers to rely upon, right? So that's why when you are creating your production cluster, you should make sure the production cluster is in multiple availability zones. Multi-region, I'll talk about it in a while, but this is not 100% required. But multi-AZ is definitely required. So create your node pool in such a way that one of your node falls into 1A, 1B, and 1C, or create different node pools, anything according to your requirement. And while we are creating the dev and staging environment, we were conscious about the resources, we were conscious about the node size. But when you deal with the production, you can be little lenient, or you can set up auto scaling, right? Auto scaling, or you can use Carpenter so that the cluster is scaled according to the requirement, or at least do it manually by providing more resources. Now, how would you achieve the multi-AZ setup? Is it done if you create nodes in multiple availability zones? No. You would also need your pods to be in these availability zones, right? Just creating nodes doesn't make any sense. Okay, you have a node in 1A, 1B, and 1C. But if your pods are not in these availability zones, it doesn't help you. So what you should do when you are creating a deployment, you can create deployment with two replicas or create it with three replicas, and make sure each replica is put in different availability zones. So that again, the same thing. If this node goes down, your one of your pod goes down, and still you have two nodes with two different pods. Kubernetes supports this. You don't have to worry a lot about it, because in Kubernetes you have topology spread constants. So just search for Kubernetes topology spread constants, my bad. And you can read about how to set up the topology spread constant. It's very simple. It's just an object end of the day. And once you define it, you can make sure the pods are placed in availability zones. But Abhishek, how about, if my company has customers across the globe? Let me tell you, this will still work for you. It doesn't mean that if your Kubernetes node is in US East 1, right? If your customer is in AP or Asia, they cannot access the nodes. No, they can still do it. But the trade-off is latency, right? They will be able to access the services, but there will be a network latency. If you don't need the network latency, right? If you want your customers to access it as fast as the customers in that region, what you should do is you should focus on scaling your production. That is setting up multi-region. I already spoke about multi-zone, and you should go for high availability Kubernetes cluster. So this is the final thing that you would do, a high scaling production grade environment. But before that, you should make sure you are good with onboarding the production environment, right? Onboarding production environment is not only about creating this nodes, creating the namespaces, but you should set up a good observability stack such as Prometheus, Grafana, right? You should make sure that there are correct liveness probes, readiness probes that are configured. You should make sure the resources that are assigned to the pods are exactly working fine. Everything to make sure that your production is running smooth. Only once you're done with level 4, you should head to level 5, that is scaling your production. Typically involves high availability as well as multi-region setup. The best way to go for it is you can set up 2 or 3 different Kubernetes clusters, right? Now I'm not talking about nodes, but I'm talking about Kubernetes clusters itself. Like you can have one Kubernetes cluster in your US region, you can have one Kubernetes cluster in the Asia region, and you can have one Kubernetes cluster in the Europe region. But Abhishek, how does this work? So this setup is called as high availability setup. So in this setup, what you typically do, so you deploy your pod, one of your pods here. You have one of your pods in other Kubernetes cluster and one or more pods in other Kubernetes cluster. For each of these services, you would create ingress. So there is an ingress for this, there is an ingress for this, and there is an ingress for this as well. You will front face these ingresses with a global load balancer. Maybe you can also use, you know, uh, AWS load balancer, or if you have any global load balancer, you can also go for it. Or maybe you can use DNS based load balancing. Using DNS based load balancing, you can see that typically Route 53 in AWS. So using that, you can see from where the request where is the origin of the request. If the origin of the request, let's say, is in US, so through your DNS, you can route the request to the ingress that sends the traffic to the US based Kubernetes cluster. Similarly, if the customer tries to access from Asia, through the DNS, you can identify that, and through Route 53, you can forward that request to the ingress, which routes the request to the Asia based Kubernetes cluster. I know this is a little complicated, but eventually, you should progress to this level if you are dealing with multiple customers across multiple regions. Overall, this is something that I wanted to share in the video. If you feel that I need to cover anything more, because Kubernetes is an ocean, right? All that I wanted to cover is how would you scale from level 0 to level 5, but there are more levels. This does not end at level 5. So you should go ahead, you should set up the controllers, you should set up the Helm charts, you should set up security. Probably, if required, you have to set up Istio, you might have to set up Kiverno. So there are a lot of things to do. GitOps, I'm not talking about all of it. My goal is to explain you how a DevOps engineer can onboard applications onto Kubernetes. I hope I have explained that clear enough. If you need anything more, let me know in the comment section, and make sure to check out our Kubernetes playlist. I might have already made videos on the topics that you're looking for. Let's say you're looking for Istio, there is already a video on that. If you're looking for GitOps, there is already a video on that. If you're looking for Kiverno, I have already made a video on that. So please check out our Kubernetes playlist. Thank you so much for watching the video. See you all. Take care. Bye bye.